Okay, so good morning, everyone. And we welcome you to beginning of this new program, and that is the 3.5 months online structural engineering training program, where we are going to learn the hands-on structural engineering by working on 4 actual steel projects. So I and Akanksha would like to uh, welcome you, all of you, to this program, and to thank you for joining this program, to those who have already joined and to those who are going to join in future. So thanks for that. Is my voice audible properly? Okay, so today is going to be the day one, and we would be having a short presentation where I just want to tell you a few things, and then we will quickly move on to the first project. So what are we going to do? I think by now all of you know that we are going to do 4 projects in this program. The first of which will be a pedestrian footover bridge. This we will be doing using StatPro, and this will be a geometry that you quite often see in your urban city centers. Most of you are from urban cities, urban places, and in your cities, in your towns, you often see these types of bridges being used. So it's a common steel structure, and that's what we are going to do in this project. So that will form our first project. Then the next project that we will be doing would be an industrial steel structure. This we will be doing using the ETABS software. So many people have this myth. Many people have this notion that ETABS is not good for steel structure design. So we will be sort of addressing that issue by doing one big project in ETABS. All right, it would be a big project. If you see, it's a 20-meter wide, 39.5-meter length. So these are the planned dimensions, and 60-meter height. That is almost 19 to 20 story structure, isn't it? If you have a general structure of 60 meters, 60 meter would roughly mean around 20-21 stories. So it's going to be a massive structure. This we will be doing using ETABS. Then the third project that we will be doing will be a big pre-engineered warehouse shed. This we will be doing using StatPro, and this will be again a quite a big structure, 55-meter width, and 101 meter is the length. So these are the planned dimensions. Eaves height will be 10-meter, and we would be using jack beams in this. What is the meaning of jack beams? We have already discussed in our introductory session. So you can just go to the introductory session to have a look at what does jack beams mean. Anyway, when we do this project, things will get clear. This we will be doing using StatPro. And the fourth project that we will be doing will be again a hospital building. This we will again do it using ETABS. So I think all of you have seen the plan of this hospital building. It's a uniquely shaped hospital building that we are going to do, and it would be done using ETABS. So 2 of the projects using StatPro and 2 of the projects using ETABS. So this will actually uh, give an overall understanding to you on usage of different softwares for steel design. So this is what we are going to do in our program that starts today. Then how are we going to do it? That is again important. So what we are going to do, that we have understood. Now how we are going to do that? So we will be having a daily morning session, just like what we are having right now. And then we will give you some time to work some things yourself. For example, if we ask you to do something during the morning session, then you can try to do it on your own during the time that you get in the afternoon. Then in the evening, again, we will have a short session where we will just discuss whatever has been done during the day, and we will have some interaction if required. This, of course, is for the people who are joining this as a regular program. Many of you are going to join this as a self-paced program also. Those who are working professionals, practicing consultants, those who are, I think, going to join this as a uh, self-paced learning program. For them, we'll just discuss how they need to do every day. So this schedule is for people who are going to join this as a regular program. It's very important to remember that this is taught, or this is designed as an hands-on program. So we expect you to devote some time to uh, do what we are asking you to do. Only then you will learn. Unless you do not do it yourself, it will be difficult for you to understand. So it's less on spoon feeding. Of course, we will tell you what needs to be done. Of course, we will discuss the theoretical aspects also, but we expect you to devote time in whatever we are telling you to do. Okay, that is very important. There is no substitute for the hours that you spend. So only when you spend some time with the project, only then you will be learning it in a proper way. So this is very important thing for us to remember. And then together, we at AuxEn and all of you together, we would be doing these projects. So it will be a collaborative effort that we are going to adopt. Yes, so we have put this slide once again. This was put in the introductory session also, but once again we have put this because many of you had this query, or many of you had this reservation that you are practicing professional or working consultant. So how can you join this full-time program? So for them, again, we would like to repeat that those who are joining this as working professional or practicing consultant can join the program as a self-paced learning program. If you get time, you can attend the morning session live. Otherwise, you can watch the sessions in a recorded format. So every session that we conduct, it will be uploaded online on our portal. Most of you are past participants, so you have seen that portal, isn't it? So it would be uploaded online within a couple of hours of conducting the live session. So for example, the morning session would be uploaded by around, let's say, 11 a.m. or 11:30 a.m. And the evening session would be uploaded by around 5:36 p.m. every day. So within an hour of conducting, you will be able to watch that session online. So even if you are not able to attend the session live, you can of course watch it online. So those who are going to join this program as self-paced program, they can watch the sessions on the portal as per their own convenience, and then they will have to complete the tasks that have been given uh, as per their time schedule. So they have to manage their time, and they should try to complete the tasks that we are giving. It is important that you complete the task within a stipulated time, because those tasks will be linked to the uh, sessions that we conduct, isn't it? So if we are telling you to do something, then whatever we have told you, maybe that we discuss in the next session. So if you have not worked on the task, then the session does not remain quite interesting for you. So it's important that you try to complete the tasks within a stipulated time. And then for everyone, and especially for the working professionals, practicing consultants who are not able to attend live sessions, we will be organizing periodic discussion sessions, let's say on weekends, so that they can also attend the live interaction or discussion session. All right, because every day they will not be getting time to attend live classes. So then for them, we will arrange some periodic discussion sessions where they can interact with us live. And all these sessions, everything, uh, and all the contents will be available on our portal for a period of 1 year. All this, what I am saying, is applicable to the regular participants also. So all the regular participants, they can also watch any session online. They can also watch any session in the recorded format on our portal. So suppose you miss some session someday because you are out somewhere or you are on a holiday or you are not able to attend, you can always watch the session online on our portal if you miss attending the live session. So this facility is available for everyone. Okay, so I just thought that we will address this issue once again. We had talked about this in our introductory session also, but we are repeating it. So we are going to adopt a two-pronged approach. Two-pronged means which has two components. So as a structural engineer, what we need is a sound, solid theoretical base and software proficiency. So you just not need the theory, but you should have good software proficiency also, because using software is the reality of the day. As structural engineers, we have to use softwares. Without software, uh, things are no longer possible now. So you have to use some software, some analysis software, some design software, drawing software. So something or the other you have to use. So software proficiency is also important, and having a solid theoretical base is equally important. Because if you do not have a sound, solid theoretical base, you will not be able to understand what software is doing. And if there are some problems with software, which generally are, there are general problems with the software that you see. So if there are problems, then you can understand the problems if you have a sound theoretical base. This is first component. As a structural engineer, you should have this. And plus, you should also have experience of doing actual projects. So you cannot just be contented with good theoretical knowledge. You also should know how to apply it on your actual projects. Okay, there are many people who are very good at theory, but they do not have the exposure and experience of doing actual projects. So those skills are also quite important. And for most of us who are practicing engineers or working professionals, or we have our own consultancy firms, the experience of doing actual projects is very important. So through this program, we are going to address both the issues. The experience of doing actual projects, of course, we are going to do 4 actual projects in this program. But then what about the theoretical base? And what about developing software proficiency? So for that, what we have done is, I think most of you know that we have added but we have added 2 online courses with the program. So to develop a theoretical base with software proficiency, we have added 2 online courses to the 3.5 months program. So these courses that we have added have been conducted in the past. I think some of you have been the participants of those courses also. I can see many people who have been the participants of those courses. So those courses were conducted by us in the past, and then they will actually be a very good primer. They will be a good starting point, and they will help you in developing a very strong base, and they will help you in resolving a lot of theoretical doubts. Okay. So for example, you work in some office, if you have some doubts, if you have some difficulty, and let's say you ask your senior a theoretical doubt. Okay. So what does your senior say? Your senior says, let's say, refer some book or refer some document, refer some text. So that's what we are going to do. Suppose we have to address some theoretical issue in this program when we are doing project, we will tell you to refer sessions from this online courses that we are going to add in your program. So this helps us in saving time, and it will ensure that we can concentrate our energy and our focus on doing the projects. So we don't want to spend our time discussing theoretical concepts over here. Of course, we will discuss when required. I'm not saying we will not discuss. So we will be discussing theoretical concepts when required. But if there is some long discussion, And if there is some discussion that we have already covered, we will guide you and we will tell you to refer these courses. So these courses will be added to your program. This is the idea that we are going ahead with. So I'm just showing you how the portal looks like. I'll give you a live demonstration also at the end of today's session. So for example, everyone will be added on a portal. Let's say this type of name will appear, and then you will see this package added to your account. Those who have joined during last week, I think they are able to access this feature on the portal. I hope everyone is able to access. Those who have joined during the last week. Yes, so you will see this type of a package added to your account. And then when you click on this, you will see these two courses added. How many of you are able to see right now these two courses? I mean, on their personal accounts. How many of you are have been using these two courses? Those who have joined last week, I think they are able to access this. Hello. Yes. Okay. So you will be able to see this. So this STC-11 that you see, this STC-11 is a detailed course on steel design and detailing. So it's a design and detailing course where we have covered everything related to steel design from scratch. Okay. When I say everything, that means whatever things you require at a basic level, all those things we have covered. And it's a comprehensive course. It's very, very detailed, and it covers everything from the scratch. There are detailed manual calculations, software verification, or connection design, everything we have discussed. Okay. Plus, we have done one project at the end. So if you have any theoretical doubt related to steel structure, you can very easily go to STC-11 to resolve your doubts. From time to time, we would be telling you to refer if there is any particular session that we want you to refer. From time to time, we will be guiding you to do that. Okay. So for example, we are discussing some compression member. We are discussing compression member design, and there is a particular point that I want you to focus more about. So I will tell you that go to STC-11 session number 13, and you will be able to watch this concept in detail. Okay, that is how it will work. The other course that has been added is STC-14. This is another course that we had conducted in the past, and this covers the design and detailing of PEB systems. So for our third project, where we are going to do the industrial shed, it would be beneficial to refer to this STC-14 program, STC-14 course. Okay, so this was a course that we conducted on PEB systems. So our third project of PEB industrial warehouse, if there are some issues we want you to go deep into, if there are some theoretical points, we will ask you to refer to this session. So these two courses are added to everyone's account, or will be added to everyone's account when they join. This is how your courses look like when you click on the portal. When you click over here, so on clicking here, you will be guided to, or you will be redirected to this type of a window, and here you can watch all the sessions. So you can see all the sessions are available to be watched. I think there are some 47 or 48 sessions in the STC-11 course. That was a detailed course on steel design. And in the STC-14 course, which is the course for PEB system design, I think there are some 32 or 33 sessions. So a lot of theoretical stuff, lot of deep concepts, lot of things on how to approach software have been discussed in these two courses. So this will form a theoretical base for you. This will form a very good theoretical base for you. And then the experience of doing actual projects, we are anyway going to do live in this program. Okay, so this is how we are going to address these two issues. Any questions till now? Yeah, I have one thing we forgot to tell you, that all of you are on mute, so you cannot unmute yourself during the session. Whatever you have to ask or whatever you have to tell, whatever query, comment, question you have, you can type it in the chat box. So when you type it in the chat box, I and Akanksha are there to have a look. I mean, we are constantly monitoring the chat box, and we would be reading whatever you are writing in the chat, and we will be answering to those things. So why have we kept you on mute? Just that it becomes very streamlined to conduct a session. Okay. Otherwise, things become chaotic if someone else is speaking and then they are asking some question. And if that question is not the question of others, then things become boring for other people. So we generally keep all the people on mute during our session, but that does not mean you cannot ask questions. Of course, you can ask questions. I think most of you have been past participants of our program, and you know that you can ask questions through this medium, isn't it? So asking questions through the chat is, I think, more convenient way of asking questions, and it becomes more easy to conduct live sessions. This is what we have felt during the past 2 or 3 years. So this is how we do it. So yeah, so any questions till now? Yes, no? You can write it in the chat box. Hello. I hope I'm audible to everyone. Okay. So moving ahead. So I hope I have addressed the issue that how we are going to have a theoretical base also, and how we are going to gain experience of doing actual projects also. Now we must remember, is my voice audible? No answer. Okay, yes. Just give me a minute. Right. So before we move ahead, we must remember that the projects are going to be actual projects. Actual projects means these are not some dummy projects, or these are not some projects which we have just taken simple grid, simple projects following a particular grid. You quite often see these types of projects being taken in your uh, courses like these, isn't it? That they will take a regular grid and everything will be smooth, easy. Okay, so these are not dummy projects. These are going to be actual projects. And the reason for taking actual projects is that when we do actual projects, because if you are doing some, if you are going to practice as a structural consultant or as a working professional, of course, you will be subjected to actual projects. Okay, so this will mean, and I think some of the participants are from the SDC-1 course also. So this means that when we do actual projects, uh, the process may not remain streamlined. Okay. So for example, if you are doing something in book, so quite often you see in books examples are given. So those examples are in a streamlined way. They give those examples so that they do not pose any difficulties. But when we are doing actual projects, and for those who have done actual projects or those who do actual projects, you might have felt that the process is not streamlined, isn't it? It's quite, I would say, chaotic. In our offices also, we face a lot of difficulties when we have to do actual project. So the process may not remain streamlined. We will have to do what is known as lot of jugaad, isn't it? We will have to do a lot of jugaad when we are working, and we will have to be street smart, and we may have to take some practical and sound engineering judgments and decisions. So we may, sometimes you may see that we are not following the Indian standard, let's say, but we are doing something that is slightly not in agreement with the code. So we have to do such things when we are doing actual projects. But every time, what is important is that your decisions have to be based on practical and sound judgment. Even in all your codes, they have a line. I don't know if you have read it or not. In every code that you see, the preface of every code, whenever you use any Indian standard, you must read the preface. Have you ever read the preface? Preface or foreword, what they call it as? Anyone reads the foreword or preface of the Indian standard? Anyone has read it before? So whenever you are using, or whenever you are going to start using any Indian standard, or for that matter any standard, you must always read the preface or foreword, because there are a lot of things that are given in the foreword, in the preface. Even when you are reading any book, suppose you are going to suppose you start reading some textbook or some course book, you should always start by reading the preface or the foreword. That gives you a very good idea of what is to follow in the uh, particular text. Why I'm telling you all this is that in your Indian standards, you will always find a line which says that it is assumed that the Indian standard which is being used by a person having good engineering judgment and good engineering knowledge. Okay. So your Indian standard also expects that you will be applying sound engineering judgment and knowledge while using the code. So we have to be street smart, and we have to take practical and sound engineering decisions. Okay, that is very important. So that actually separates a good engineer from an engineer who is only relying on the theory. So when we are doing actual projects, we have to keep these things in mind also. All right. So you will see a lot of these things when we do our project. And of course, the challenges, we will be facing challenges. There will be some days when we are not able to do a particular thing because these things are not choreographed. We are doing it live. Everything we are doing is live. So there will be some days when we face some challenges, but then we will of course overcome them. And when we overcome them, the manner in which we work our way around them will make us better engineers. So that is the intention of taking actual projects, that when we face the challenges and when we work our way around them, it makes us better engineers, isn't it? So you might have experienced this when you do your projects. Most of you are practicing engineers. So when you do some actual thing, you will face some difficulties. And when you work your way around it, then only it gives you a good learning. So it's very important to remember these things, that the process may not be very streamlined and we may face difficulties. So for every project, what will be the steps involved? So I would just like to ask you, suppose you are given a project. All right. So as a structural engineer, what do you think should be the step-by-step process of doing it? Yes, anyone would like to answer now? You can write down whatever you have to say in the chat box, because every one of you are on mute right now. So whatever you have to say, just write it in the chat box quickly. So what I'm asking is that for any project that you do, what do you think should be a step-by-step process? Yes. Anyone? Hello. As soon as you get a project, let's say a project comes to you, you are a structural engineer, consultant, or you are working in some office. So project is given to you. So what should be, okay, what will be the input for you as an architect, as a structural engineer uh, who is going to do a particular project? What will be the input? So the input will be architectural drawings. Okay. Or let's say in case of the industrial project that we are doing, the input will be what is generally called as a general arrangement drawing. Okay, so these will be your inputs. Once you get the input, what will be your first step? Uh, yes, so Mr. Sandeep is saying architectural or functional planning first, then structural framing plan. Yes, and then Mr. Kannan is saying design basis. What do you mean by design basis? What do you mean by design basis? Design basis. See, design basis, yeah, design basis can actually come, I would say, design basis means to finalize the design parameters, to finalize the design standards, to finalize the design methodologies that you're going to use. That uh, yeah, that may actually come parallelly to what I'm asking right now. So of course design basis is important, but that can come parallelly to what I am asking right now. Okay, so my question is on a slightly different uh, it is in a slightly different context. So once we get inputs, our inputs will be in the form of architectural or general arrangement drawing. So first things will be Lakshmi saying detailed study of architectural plan and layout preparation. Yes, so first step should always be uh, preparing some. Okay, so Rahil has given a long list. Basic framing, correct. So I also agree that initial planning, we should always do some initial planning and try to prepare some structural framing system. Okay, so understanding of what structural framing system you have to use and doing some initial planning is very, very important step. Okay, and I will say that this step separates a good structural engineer from an average structural engineer. So making ETABS models or making StatPro models is not structural engineering. That even a 8 standard or a 9 standard person can do it, isn't it? It's just operating computer software. So making models on ETABS StatPro is not a big deal. Anyone can make it. But what is more important is to do some initial planning, is to sort of finalize or is to understand what structural framing system we will have to adopt. So this is very important first step. And this thing only comes with experience. So if you are a fresh structural engineer, you might have noticed that suppose you are working somewhere, your bosses don't give you this work as a fresher, isn't it? As a fresher, what you are asked to do. So as a fresher, you may be asked to directly go to model preparations, isn't it? So when we also did our first job, we were just directly given a framing plan and we were asked to model it on ETABS. Okay, so as a fresher, you may not be able to do this thing in an efficient manner, but as you gain experience, it's very important that you develop this thing. So initial planning and structural framing system. When I say structural framing system, what do we mean? I'll talk more about this later, but because many of you are conversant with RCC, let me just ask you, what are the general RCC structural framing systems that you see? What are the general RCC structural framing systems that you see? Why am I asking a question about RCC? Because many of you are conversant with RCC design, that's why. Yes, tell me, what are the general structural framing systems that you see in case of reinforced cement concrete structures? So I will divide it further into two parts. One can be the gravity resisting structural system. So I'm writing gravity load resisting structural system, GRSS, and let me write lateral or I'll just delete this and I'll write it as L, gravity load resisting system, GLRS, and lateral load resisting system. So in RCC, what are your gravity load resisting systems? So you can have a simple beam column frame. Okay, you can have a beam column frame. What else can you have? What else can you have? Then Mr. Archit is saying DAMS, dams. Dams. You can have a load bearing walls type of a system, isn't it? Load bearing walls. So one system can be beam column moment frame system. The other can be a load bearing wall system. What is the other system you can have for gravity loads? So I think you can have a flat slab system. Okay. Hello. So these types of systems are one of the most commonly used systems in case of RCC structures. In RCC structures, what are the lateral load resisting systems adopted? What are the lateral load resisting system adopted? Lateral load means to take care of earthquake, wind, etc. So what are the lateral load resisting systems? So they can be moment frame. Yes, moment frame. That is beam column system. So moment frame system is common to both. Moment frame is a system to resist gravity loads also. It is a system to resist lateral loads also. So moment frame is common to both. Then you will see a RCC wall system, RCC structural wall. Okay, which we generally call it as shear walls, though shear wall is not a very appropriate name. But the commonly we use this shear wall term, though it's not very appropriate. Okay. So RCC structural wall system to take care of lateral load resisting, to take lateral loads. The other system which you do not quite commonly see can be a bracing system. Yes, correct. What Akash is saying, bracing system, though not quite common in RCC structures, but you see these type of systems being adopted. So if you see a famous John Hancock, no, is it the John Hancock in Chicago? Yeah, I think the John Hancock building in Chicago, it uses the periphery bracing. All right. So it uses a periphery bracing system to take care of lateral loads. So you can have a moment frame system. You can have RCC wall, RCC structural wall system. You can have a bracing system. So all these are your examples of lateral load resisting system. Akash is saying dampers are used as lateral systems. No, so see, dampers cannot be called as a lateral system. Dampers, of course, they help you to tone down the lateral loads, but still, I would not personally like to call them as lateral load resisting system. They just tone down your lateral loads. Okay, but finally, it has to be transferred to the ground in a proper way. So all these systems that we are talking about are going to transfer the loads to the ground in a proper manner. Okay, so the understanding when to use a particular system is extremely important. Similarly, in steel structures, what are the common systems you will see? Yes, tell me. In steel structures, what are the common gravity load resisting system you see? And what is the common lateral load resisting system that you see? So to take care of gravity loads, you can have a moment frame system, just like RCC. In steel structures also you can have a moment frame. Moment frame will comprise of beam column. You can have a pin supported frame also. Pin supported means columns and beams pin jointed with each other. So it will be a pin supported frames or pin jointed frames, I will say. Okay. Then you can have some trust systems. We'll be talking more on all these things later on. You can have some trust systems, but I'll talk about trust later on. So I'm not including over here. And in steel, to take care of lateral loads, mostly it will be either a moment frame, which takes care of the lateral load, or it will be a bracing system, which takes care of the lateral load, as Rahil is saying, or very less used, though you see in some structures in Europe or in Americas that they use steel walls, steel structural walls. Okay. So they are called as plate walls or wall plates. So steel structural walls, that means there is a complete plate. Just like you had RCC structural wall or shear wall, similarly you have a wall made out of steel plate in elevation like this. It's quite rare to see a steel structural wall, but there are examples where steel structural walls have been used to resist lateral loads. Okay. So these are some of the common systems that you see. We'll be talking more about it as we move ahead, as we go ahead. So this thing, to understand that what will be a structural system you will adopt and how you are going to do the initial planning. This is extremely important first step of doing any project. So we will also be doing, or this will be our first step when we are going to do any project. Good. Once we do that, what shall be our next step? So once we do our initial planning, once we decide some structural framing system, we will do the modeling in ETABS or StatPro. So two of the projects we will be doing in StatPro, two of the projects we will be doing in ETABS. So once we plan, or once we do the initial level planning, once we sort of finalize the framing system, then we will do a preliminary model on ETABS or StatPro. Then we will do extremely important step, that is going to be the load calculation for gravity loads and lateral loads. So for all the projects, we will be doing a detailed calculation for gravity loads and lateral loads. For this, we may have to use different Indian standards. We may have to use Indian standards for wind loads, earthquake loads. Okay. We may have to use Indian standards for roads and bridges. So whatever is required, we will be using that. Okay. This is extremely important step, and most of the times, most of the engineers struggle with this step. I have seen many people, even experienced structural engineers, struggling with proper load calculation and then load application. So it's not only enough to calculate the loads properly, but it is extremely important that you should be able to apply these loads in the software. Okay. So this we will be doing as a next step. So therefore I have written it as a twofold step. That first is the load calculation and then is the load application. Actually, I always say this, but load calculation is never taught in any of our subjects during our graduation. I mean, during our undergraduation and even during our post graduation. There is no independent subject which teaches us correct load calculation, isn't it? There is one course that you generally have on earthquake load calculation, but then it does not tell you how to apply properly on model, what to do. All those things are never taught. So load calculation, load estimation is very, very important. And then to be able to correctly apply it on model is again very important. So sometimes your model may not help, your software features do not help you to apply load very easily. Then you have to do some adjustments, you have to do some jugaad to apply those loads properly to your model to correct the to get the desired results. So these two things are very critical. Good. We will be following these steps in every project. Okay. After this, we will be doing the analysis of our superstructure, again using the softwares ETABS or STAD. And then we will be doing some design iterations to finalize the optimum design. Okay. So our entire design process is iterative in nature. I think most of you know this. But just I would like to throw some light on it. So why is our design process iterative? Who can tell this? Iteration means where we have to do trial and error, where we have to do multiple iteration. I think everyone understands. So iterative process of design. What do you mean by this? Tell me. So we assume some initial section. Okay. After assuming initial section, we do the analysis. Now someone may ask, or it may be a common doubt, that what is the purpose of doing design? Let's say we are doing this project. What is the purpose? What is the purpose of designing a project? So purpose of designing the project is to find out the sizes. Isn't that the desired output? Hello. Suppose you are doing this bridge project. You finally want to find out the sizes of members that you want to use or that you can use, isn't it? So that is actually the desired output, to find out the sizes. So this is our desired output. Now I am saying that you have to take these sizes, otherwise you will not be able to run the analysis. If you do not assign some preliminary sizes, then you may not be able to run your analysis. So now here we are in a problem, because this was the output that you are looking at. The entire expectation or the entire the desired result of designing a project was to get the sizes. Okay, but so this was an output for you, but now I am telling you that this has to be an input, otherwise the analysis will not be performed. So there is a big problem that we have. Okay, so what do we do? So therefore, to begin with, did you understand the problem? The problem is that what was your expected outcome, or what was the expected output, what you wanted as an output. I am asking you to use it at an input stage. That is the problem I am asking. That is the problem that we will be facing. Okay. And why so? Because unless you do not give some section properties, unless you do not give some section sizes, your analysis will not be performed. Why your analysis will not be performed? Because all these systems are indeterminate or redundant systems. So the stiffnesses of these systems play an important role in the analysis outcome. For example, if this is a beam, simply supported beam, and I apply some load on it, let us say I apply a 20 kilonewton per meter UDL, and this beam is 8 meter long. What will, and pin supported on both sides, pin and roller. So what will be the bending moment at center? Simply supported beam, UDL case. What is the bending moment at the center? So bending moment at center is WL square by 8. So what is the bending moment? 160 kilonewton meter. Yes or no? So does this bending moment depend on the size of beam? Does the bending moment depend on the size? So for example, if this size was 200 by 500 and then I change this size to 200 by 800, will the bending moment change? Will the bending moment change? No. Why it will not change? Because this system is statically determinate system. Okay, this does not have any redundancy, so the bending moments don't change. But if you have a system that has static indeterminacies, then the analysis results, suppose I have this type of a system, okay, and then let's say I have some beam over here also. Now this analysis depends on the cross-sectional properties, isn't it? Yes. So we need to know the moment of inertias, we need to know the flexibilities, or we need to know the stiffnesses of these sections in order to derive analysis results. All right. So therefore, in indeterminate systems or in systems where there is redundancy, you need to have the section sizes in order to carry out analysis, because a change in section sizes changes the analysis results. Okay, so the problem that we face is that in redundant systems we have to have some section sizes in order to run analysis. The problem is that this was the expected outcome, this was what we were wanting to achieve, and now I am saying that you have to use this as an input. So what do we do? How do we solve it? So we assume some sections to begin with, isn't it? We assume some sections to begin with. Do you understand? Hello. So initial section sizes to be assumed. How do we assume it? How will I assume it? On what factors, on what parameters will you assume it? How will you assume? So do I have to assume, let's say, ISMB 600, or do I assume ISMB 100? How do we assume it? So for that we require some, yes, for assumptions we require, let's say, some thumb rules plus some experience. Okay, so some basic thumb rules or some basic experiences, past experience will help us in assuming some initial sizes. For example, if once again I take case of RCC, in RCC I think all of us know that if the span of my beam is, let's say, L, then what is the general depth that we start with for continuous beams, let's say? So the depth that we generally start with will be around L by 12 to L by 10, isn't it? So what is this? This is your basic thumb rule. Okay, so if you follow this thumb rule, then your initial section sizes would be I would say quite close to the final sizes. All right, so some thumb rules or some experience that we have derived from past projects, that we will apply to assume our initial sizes. Once we assume our initial sizes, then we do the analysis. Once we do the analysis, then we get the design output. Are you able to understand? Quick yes, no? Hello. Now in case of steel structures, because we are going to do steel design in this program, the design output in case of steel structure, you get it in terms of what is called as a utilization ratio. So whether you are using StatPro or whether you are using ETABS, it gives you output in terms of utilization ratio. So utilization ratio means that out of the available capacity, how much of the capacity has been utilized. Okay, so you can say it's a ratio of demand upon capacity. Demand means how much of forces, moments, shears, whatever is coming on your member and how much it can take. That is the capacity. So if the demand is, let's say, 60. I'm not writing the units over here. Units can be anything. And the capacity is, let's say, 80. So the structure, the member, this is member level. Always remember, when I say utilization ratio, it is a member level output. So my member, let's say it's a column, it's a beam, whatever. So my member has a capacity to take 80. I'm not writing the units right now. And the demand is 60. So what is the utilization ratio? What is the utilization ratio? Hello. The utilization ratio will be how much? 60 upon 80. Yeah, simple, 60 upon 80. So utilization ratio will be 60 upon 80, 0.75. Is it clear? Is this concept clear? Utilization ratio. So whenever we do steel projects, our outputs, the softwares give, whether we are using ETABS or whether we are using StatPro, the outputs are always in the terms of UR or utilization ratio. So now how does it help us? Let's understand. So you get some utilization ratio. The goal of a structural engineer is to achieve optimum design. Okay. The goal of a structural engineer is to achieve optimum design. What is the meaning of optimum and how it is different from safe? If I say I want to achieve a safe design, and if I say I want to achieve an optimum design, how is safe design different from optimum design? Hello. Yes, tell me. If I again give you an example from RCC, suppose I am designing a G+3. This is an RCC example. Suppose I am designing a G+3 building with regular column spacings, let's say, and I take a size of 1000 by 1000 column size. So in almost all the general cases, if my building is a simple geometry, it is following a regular grid spacing. All right. So is it safe if I adopt 1000 by 1000 column size? Is it safe? What do you think? Hello. If I take a general G+3 building and it is following your regular column spacing, let's say 3 or 4 meter columns, not loaded very high, general residential loadings, and if I provide a 1000 by 1000 column, 1000 mm by 1000 mm column size, what do you think? Will it be safe or not? Hello. Most of you will be able to answer this, that prima facie it will be safe. All right. Yeah, it will be safe. It will not fall down. So it will be safe, but it will not be optimum. Okay. So when the concept of economy enters, when cost enters into the equation, then the optimum word appears. Okay. So most of you are writing in the chat box correctly that when the concept of economy, okay, enters into the equation, then safe design is not required. What we require is optimum design. So as most of you have written correctly, Shraddha ji has written, Kandan has written, Sandeep has written, Archit has written, Akarsh has written. Most of you have written this. What I just wanted to say, that safe designs may not be economic. Okay, they may not be economic. They may not help you to achieve economy. So as a structural engineer, economics plays a very, very important role for us. All right. India is not a country where we like to spend money. isn't it? We don't like to spend money unnecessarily. So as structural engineers working for the society, we have to keep this thing in mind, that the structures that we design have to be economic. All right. They have to be designed in such a way that you do not unnecessarily spend money. I'm not saying it should not be expensive. They can be expensive, but unnecessarily we should not be spending money. So our design has to follow those concepts also. We remember when we used to work, I and Akanksha used to work in Pune. We used to work at a multinational consultancy firm, Dar Al Andasa. Have you heard that name? Anyone? Dar Al Andasa. Yes. So it's a multinational consultancy firm in it's a Middle Eastern company, Lebanon based. They have their offices in Cairo, Beirut, that is the capital of Lebanon, Cairo, that is the capital of Egypt. I think they have an office in Dubai and Pune. So why I'm telling you all this is because there we used to do projects for the Middle Eastern clients. There they are not very much, I would say, concerned with the cost of your project. All right. So they have a lot of money to spend, a lot of petroleum dollars. So they are not very concerned about the cost as such. So we used to provide all reinforcements that we used to provide. We used to do mainly RCC designs. So all reinforcements that we used to provide would be a mesh-like reinforcement. All right. In slabs, it would be a mesh, top-bottom mesh, both directions. Okay. In India, how do we provide reinforcements in slab? In India, how do we provide reinforcements in slab? Generally, we would be providing bent-up bars, isn't it? Why do we provide bent-up bars? To achieve optimum designs. So we try to provide reinforcements where it is required. All right. So there, when we used to do Middle Eastern projects, we were not very much concerned about the cost. We used to provide mesh-like reinforcement, top, bottom, no extra, nothing. Whatever is the maximum steel, just provide it in the form of mesh. Done. So there the equation is different. All right. There the labor is expensive. So they don't worry about extra cost that you put in reinforcement as long as it's easy to construct. All right. And the concept in India is different. We have to be very cost sensitive. We are a very cost sensitive society. We don't like to spend unnecessary money, isn't it? So as a structural engineer, what is required is to achieve optimum designs. All right. This is very important. And this is a great skill to have, to achieve optimum designs. All right. By optimum, it should not be unsafe. Remember this thing, that people think that when I say optimum, it has to be unsafe. No, it has to be safe. Plus, it has to be cost sensitive also. Yes, Sandeep ji is saying they are concerned with time. Yeah, there the equation is different because the labor is expensive. They don't have any problem with using large amounts of concrete and reinforcement as long as time is saved, as long as it's less labor intensive. So different geographies, different limitations, different approaches. All right. So, right. So we would be following, or we would be focusing on the optimum design. Now, how do we do it? The iterative process of design. Let me just explain it very briefly. So suppose I take a section ISMB 600, initial section. For some structure, I choose this member and I assign it a size of ISMB 600. I think all of you know ISMB. What is the meaning of ISMB? I would be talking more on these things later, but I think you all of you know ISMBs. ISMBs are Indian standard medium beams. So these are hot rolled sections, hot rolled beam sections, following a standard geometry, following a standard width, following a standard depth, following a standard flange width, web thickness. Everything is standardized. Only then we call it as ISMB 600. So suppose I use an ISMB 600. I do the analysis and plus I do the design. This will be done by STAD, and then I get a utilization ratio of 0.3. So yeah, one thing, what can be the maximum allowed utilization ratio limit? So because it's a demand by capacity ratio, till what value we will allow our UR to go? So we will allow it to go to 1. So 1 will be a limiting value for us. All right. In some cases, we may have to restrict it to, let's say, even lower value. That depends on some other considerations which we will be discussing. But yes, you can take it to 1 and it should not exceed 1. So if I choose ISMB 600, I do the analysis design, I get the UR as 0.3. This will be an output that your software will give. So is this safe? Is this size safe? Yes, it's safe. It is safe because the UR is 0.3. You could have, so you are basically using only the 30% of its capacity. So it is safe. But is it optimum? Is this optimum? It is not optimum because you are only using 30% of the capacity. You are not using this section to its potential. All right. So what you would like to do, you would like to do some design iterations. So let's say I may wish to reduce the size. So I reduce this size to ISMB 400, let's say. So if on reducing the size to ISMB 400, I get some UR of 0.6. Again, the same question. It is safe, but it is not optimum. Then I again, yeah, just again, one thing I should have told you. When I change this size from 600 to 400, why do I need to rerun my analysis? Why do I need to rerun my analysis? So I need to rerun my analysis on changing sizes because, as I told you, that when the structures are redundant, or they have indeterminacies, the stiffnesses affect your analysis outputs, isn't it? When the structures are redundant or when they have indeterminacies, the stiffnesses will affect the output, analysis output. So when I change the size from, let's say, ISMB 600 to ISMB 400, I have altered the stiffness. So the design outputs will change, and sorry, analysis outputs will change. All right, the bending moments, mainly the bending moments change. So to take that thing into account, to consider that effect, we will have to go back and rerun our analysis. Is it clear? This is very important. Whenever you change any size, whenever you alter any sizes, you should and you must always rerun your analysis. Why you need to rerun? Because a change in stiffness leads to changes in analysis results. Extremely important thing to understand. And I'll be repeating this quite often henceforth. So you rerun your analysis, you rerun your design, and then you get your UR as 0.6. So again, it is safe, but let's say you think it's not optimum. So again, you go back. Go back means you again go to your basic initial level. Again, you change the size, and again you rerun your analysis. It's extremely important to rerun your analysis. So you rerun your analysis. You take this size now, 300. You rerun the analysis. You redo the design, and now you get a UR of 0.9. Okay. So now you say that it's okay. As a designer, you have decided that you are going to limit the UR at 0.9. So this is called as design iteration. Do you understand this? Hello. Yes, tell me. Is it clear? Design iteration. The design iteration could have worked in an opposite way also. How it could have worked in an opposite way? Suppose I used a size of ISMB 75. Suppose I used the initial section size to be ISMB 75. 75 comes, isn't it? ISMB 75. Yeah, we have 75. No, or it starts with 100. Yeah, 100. That's what. Yeah, sorry. I also thought on writing ISMB 75 that something does not look good. It's 100. Sorry. So we take ISMB 100. Yeah, ISMC 75 is the minimum channel that you get, but for the minimum beam, it is ISMB 100. Usually, your channels are lighter than your beams when it comes to the strength. Okay. So when you compare ISMBs and ISMCs, usually ISMBs are heavier when it comes to the weight, heavier when it comes to the strength. The only exception being that ISMC 150 is stronger than ISMB 150. Okay. For rest of all the other sections, you will always see that ISMBs are more strong than the corresponding ISMCs. Just a thing I wanted to I thought I would share. Anyway, so let's say we get ISMB 100 as our initial section, and we do the analysis. So this time, what do you think will be the UR? Will it be more than one or greater less than one? Let's say I have taken this as the initial size, ISMB 100. I do my analysis and design. What will be the UR? So we feel that it should be greater than 1 or in the 0.99 and thereabouts. Why? Because ISMB 300, what we just saw was giving you a UR of 0.9. So if I'm taking a very small section, of course my UR will be greater. Okay. So if my UR is greater than 1, is it safe or unsafe? Hello. If my utilization ratio, when I take ISMB 100, if the UR is greater than 1, is it unsafe or safe? So this time it is unsafe. All right. This time it is unsafe. We may allow uneconomic designs, but we can never allow unsafe designs. So if UR is 1.2, it's not allowed. What do? We go back and we change the size. Let's say we change our size to ISMB 200. And then I again do the analysis, redo the design, and suppose I get a UR of 1.1 or 1.05. Again, this UR is unsafe. Again, we go back, we change the size, and we take ISMB 300, and then we redo the analysis, we do the design, and then finally we get a UR of 0.9. So did you follow? Our iterative process may work in either directions. So in one direction, it may work in this way, that we have taken very large section sizes and we want to achieve optimum solution. So we may reduce the sizes. In the other direction, it may work in this way, that we have taken very small sizes, which makes it unsafe. So we may have to do the iterations till we reach safety and optimization. Is it clear? Hello. Yes or no? Right. So if I write it over here, if I work in this direction, we are working towards safety. And if we do the iterations in this direction, we are working towards optimization. So the intersection of optimization and safety is what you are targeting at. All right. So this is called as the iterative process of design. Now, what may be the difference between a structural engineer who has a lot of experience and an engineer who does not have a lot of experience? What will be the difference? The difference would be that an experienced structural engineer may do this process in very small iterations. Do you get it? So an experienced engineer, just by looking at the structural system, just by looking at the loads that are going to be applied on the structure, he or she may figure out that around, let's say, 400 or 300 or 200 may be the size. So he or she may be able to do this work in, let's say, 1 iteration or 2 iterations. For an engineer who is not experienced, he or she may take 4 or 5 iterations to reach optimum solution. Okay, so the only difference between an experienced person and a person who may not have that much experience is the number of iterations that may be required. Otherwise, everyone has to follow this iterative process of design. Do we get it? Hello. Good. So I just thought I will throw some light on this. Most of you are aware of doing these things. Most of you actually do these things in your projects. It is just that we have brought out in a written form. So design iterations, I go back once again to the step-by-step process that we will be adopting. And so initial planning, then we do the modeling, load calculation, load application. We choose some initial sizes. So initial sizes are taken, and then we do the analysis. Then we do the design iteration to finalize the optimum design. So all these steps we will be doing. Then once we do the iterations, then we can finalize the structural steel elements, beams, columns, bracings, whatever, truss members, whatever, we can finalize them. Once we do the member level design, or once the members are done, then in steel structures, what is the other component? What is the other component in steel structures? So with members, another important thing is the connection design. So once our members are finalized, then we will proceed to connection design. Connection design in this program we will be doing either through some quick manual calculations, or using some Excel spreadsheets, or we will be using a good software that is called as Idea Statica Connection. So through these 3 approaches, as and when required, we will be doing the connection design. After we do connection design, then we will be doing the drawing development work using AutoCAD. Now in steel projects, the drafting work is slightly more difficult. Okay. So even if we know AutoCAD, even if we are good at AutoCAD, we can draw well in AutoCAD. It's slightly more difficult to do the complete drafting work for steel projects. So it is better if those works are left to the experienced people. So we will not be doing the drafting work ourselves in AutoCAD, but we will be discussing on drawing development. So what details, how the details need to be prepared, how those details should be included, those things we will discuss, but we will not be doing the complete drafting work on AutoCAD. In our earlier program that we just concluded on RCC projects, we did actual drafting work also for 2 of the projects. All right. So we actually did the entire drafting work. We made the entire drawings also ourselves, but that was RCC. So we did that. Here we will not be doing it. We will be discussing drawing development, and then it is best left to the experts. So generally, if you are working as a structural engineer in an office, let's say, there will always be some draftspersons for you who will be doing the drafting work. Or if you work on your own, you can always hire the services of some expert draftspersons. All right. Okay, so then after our members are finalized, after our connections are finalized, then we will be doing the drawing development. Again, I repeat, we will not be doing the entire drawing drafting ourselves. We'll be doing only the drawing development work. And then after this, we will prepare calculation reports, because in most of the projects these days, people ask for the calculation reports also, isn't it? Even if those who are asking do not understand a single line of what is written in the report, still they ask for report. So they will always say, please submit the report, even if they are never going to read it. But those many pages they want that they should be given. So we will prepare design reports in simple Word format, nothing rocket science about it. Simple Word documents will prepare. Most of you or many of you must have prepared projects or dissertations or thesis during your coursework in undergraduate or postgraduate studies. So similar thing we would be doing when we prepare calculation reports, isn't it? And then we will be preparing BOQs. Again, BOQs, preparing BOQs in steel projects is quite simple because you do not have lot of items in steel projects, isn't it? In RCC projects, you have a lot of items. You have plaster, paint, waterproofing, reinforcement, this, that. But here we don't have items as such. Only 4 or 5 items, and you are able to prepare the BOQ. So then we will prepare the BOQ. It is important to note that we will not be doing any foundation design in this course. I have told you before also, in this course we will not be doing foundation designs or substructure design. There is a reason for it, because if we enter into substructures, then for each project we may have multiple possibilities of substructure. All right, you may have a pile, you may have isolated footings, you may have to give rafts. So for any project, all these possibilities are there. So because we want to focus on steel design, we will be stopping at base plate level. So when you reach your base plate, that's where we stop. It may seem to be slightly unfair, but why we are doing it this way is that we want to focus on steel design. And if we enter into substructure, then it will lead to a lot of other issues which we do not want to discuss and divert our attention for. So therefore, we are going to stop at the base plate level. I think most of you, yeah, anchor bolts, of course, base plate plus anchor bolts. So we stop at the anchor bolt level. Okay. Right. So this is the process we will be following for all the projects. Any questions you have with regard to this discussion? No questions. Very good. So then I think we can jump straight into our first project. All right. So let us jump into our first project. So from today, we will be doing our first project, and that is going to be a pedestrian. Sandeep is saying we can discuss on foundation. We can discuss on foundation means? Okay, so in the meanwhile, he types down. Let us jump into our first project, and that will be a pedestrian footover bridge. Now, how many of you have seen footover bridges? How many of you have seen footover bridges? Yes. I think every one of you has seen footover bridges in some form or the other, isn't it? Most of us, or I think all of us, live in urban centers, urban towns, cities, metropolitan regions. So everywhere we go, we see some pedestrian footover bridge. The most common example of footover bridge you will see would be at the railway stations, isn't it? The footover bridge which connects platforms is a good example of a pedestrian footover bridge. Or these days you see them at busy road crossings in big cities like Mumbai, Pune, Bangalore. You see them at railway stations, metro stations. You see a lot of pedestrian footover bridges. So this will be our first project, a pedestrian footover bridge. What is the meaning of pedestrian? What is the meaning of pedestrian? Yes, tell me. Pedestrian. So pedestrian, yeah, where only people are allowed to move. All right, only people are allowed to move. No vehicle. Only people can walk. There are no vehicles allowed. Okay. So this is not allowed. Only this is allowed. This is good figure, isn't it? Is this good figure? So only people are allowed. No vehicles, no vehicular load is allowed. In some pedestrian bridges, they may allow cycles. Bicycles, they may allow. So non-motorized bicycles, uh, they may allow. How does your bicycle look? Something like this. Bicycle is actually a very good example of a truss. I don't know if you have observed this. Bicycle is a very good example of a truss system. So you have something like this, isn't it? No, how does a bicycle look like? It's a triangular frame actually. It's a triangular frame, two tires. No, but then where will be the handle? Inverted triangle. Acha. Then how will be the tires? Where will be the tires? Acha, tires are chain. Two triangles. Okay, inverted two triangles. Ha, like this. But then where will be the handle? What has happened to me? I'm not able to imagine a bicycle. I will see some picture and then I will draw. Okay. Handle will be here, I think. No, but then how to connect it with the chain? I'll have to look at some image and then draw. But anyway, you have understood, isn't it? Acha, Archit is saying middle one is chain. But then it cannot be the form part of your truss. I was just thinking how your truss. Okay, anyway, I'll draw by looking at the image later. So bicycles may be allowed and people are allowed, but no vehicular traffic is allowed. Okay. So that is called as a pedestrian bridge. So this will be our first project, pedestrian footover bridge. And this is the plan view. And this is the proposed elevation. So what I will do is I'll take you to the AutoCAD drawing. Maybe in the next 5-6 minutes, I'll just introduce the drawing to you. All right. So this is the AutoCAD drawing that you can see on your screens. Can you see this? Hello. Can we all see this AutoCAD drawing? Yes, no, yes. So this was an input drawing that was given to us by the architects or by the people who wanted us to design this bridge. All right. So this was the input drawing that they had given. So this was a very big intersection, a very wide intersection in one of the cities of Madhya Pradesh. So this is the big intersection. There are 4 roads that are intersecting. 1, then 2, then 3, okay, and then 4. Can you see this? 4. Let me use 4 colors. 4. Okay. So these 4 roads were intersecting and these roads were quite wide. So very wide roads intersecting, and therefore this circle was very big circle. This intersection was a very big circle actually. I mean, there was no rotary as such. There was no constructed rotary, but this entire intersection was quite big. All right. So if someone had to cross as a pedestrian, he or she needed to walk a very long distance. Are you following? Do you understand how this drawing? Are you able to get this drawing? Understand this drawing? Are you able to make out the pedestrian? Sorry, are you able to make out the roadways? These are your roadways. I'll just mark once again. These lines that you see are your roadways. This is the, what do you call it? Median. This is your median. And then you have, I think, how many lanes? 1, 2, 3, 4. 1, 2, 3. Oh, 4 lanes. So you have 1, 2, 3, 4. Oh, 5 lanes. I don't know if they have drawn it correctly or not. So you have very wide road over here. You have very wide road over here. You have very wide road over here. And you have a very wide road over here. And it was one of the very busy intersections. Yeah, divider or median. We call this as median also. If someone can just inform. I think we call this as median. The divider that we have in between, in the middle of your road, that divides the two lanes of the two directions of traffic. Is it called as median? Yes. Okay. So this was a very busy intersection, large intersection, and an intersection where a lot of people used to cross this intersection on foot. Why? Because there were buildings where people go for work. There are shopping complexes. There is a market. You can see there's a big commercial complex over here. So this was an intersection where a lot of people had to walk on foot. So if a lot of people have to walk on foot, there is always a risk of accident, or there is always a risk of traffic obstruction. Okay. So what they planned that they planned to overhaul the entire pedestrian movement in this region. Okay. So they wanted a complete solution to overhaul the pedestrian movement. Movement means not the bending movement. People going from one place to other place, movement. So they had to completely revamp and overhaul the pedestrian movement, and therefore they come up with this scheme. So this is the scheme they worked out, and we were involved in doing the design of the pedestrian footover bridge. So the footover bridge that they planned was from here. Can you see these orange arrows? Hello. So this is the footover bridge that they planned. Yes, can we see this? These orange arrows. And it was planned as a two-way pedestrian bridge. Two-way means people in both directions can walk and cross. Okay. So this was planned. Mr. Kandan is asking, you have any site photos? I may have the site photos of the intersection. I may have the site photos of intersection. The big intersection that you have. I'll try to show it. Okay, so are you able to imagine this, everyone? So this was the pedestrian bridge that was proposed. Okay, and this was the alignment that they proposed. So what you can see is, I'll just now zoom into this. The green lines that you see is the pedestrian bridge line. So this line, then this line. All right. Then if I go to this line, all these lines represent the alignment of your pedestrian footover bridge. Okay. So basically you could walk from one diagonal corner of this intersection to the other diagonal corner. So you could walk from this point to this point through this alignment. Why did they not plan like this? They could have planned a straight line. Why did they plan it in this way? Why did they plan it like this? Why not the blue alignment? Straight line. Yeah, so because what Ryle is saying, that straight line would have become a very large span. This span would have been become very big. And suppose if to control the span, if I had to provide some central column, what would have happened? If I had to provide some central column over here, what would have happened? That column would have come right in the middle of the road, isn't it? This is your flowing road, traffic from all directions. So I cannot have a column or a pier or a pedestal or a pylon over here. It's not possible. So therefore, this alignment was not taken, and instead we took this alignment. We did not take it. The transport engineers who did this planning took this alignment. Is this clear? By taking this alignment, what they were able to do, that they were able to have some columns. So if you see this pylon, do you see this word pylon? This pylon is nothing but a vertical columns that we have taken over here. And if you see, this pylon has been taken inside the small traffic rotary. This is not called rotary. What is this called as? These types of things that you see, dividers, traffic dividers. What do they call this as? Traffic islands. No, there's some technical name given to it. You get this, right? If there's a traffic from here, then this traffic has to turn like this. Then you give something over here on the road. What are these called as? Dividers. Islands. There is some technical name to it. Pavement. No, pavement is your road. There is some name given to this obstructions that you create for proper traffic flow. I'll just search and then tell you. Did you get what I'm saying by this? What is this? So this will be a raised area which has been designed so as to have a proper traffic movement. Okay. So anyway, your traffic is not going to be over here because this is an island. This is an island raised from your road level. So this has been designed for the proper traffic flow. So this will be raised. Anyway, this space is not being used by any traffic. So therefore, we planned a pylon over here in this traffic island. Is it clear? Hello. So when we have columns over here or pylon over here, it does not obstruct with your traffic flow because anyway, this was a raised island. So first pylon was taken over here. Then the other pylon was taken in the next traffic island. So if you see over here, there is another traffic island over here. Why this has been provided? For the smooth traffic flow from this side to this side. So if a traffic has to turn left, they can just use this and turn left. So this was a traffic island. And on this traffic island, the next pylon was taken. This was a traffic island. It was a raised platform above the road level. There was no cars that were going to come on this, and therefore this column or pylon was planned over here. Is it clear? Hello. Rahil is asking, is the pink block near the median on left side another pylon? This one? No, this is something else. This is not part of our this thing. There was no pylon here. Okay. Then the next pylon was taken. Next pylon that was taken was on the next traffic island. All right. The next pylon that was taken was on the next traffic island over here. Okay. So this was a traffic island. If some traffic is coming from this side and the traffic wants to move in the left, take a left turn, Then to control that left turning, there was this island given, and on this island, another pylon was taken. Clear? And of course, pylons were taken over here, where out of your intersection in this region, one pylon was taken. And similarly, a pylon was taken in this region also. All right. This region. So overall, if you see, by providing this alignment, what we have ensured that none of the traffic is getting obstructed, and all the vertical pylons or columns that we have taken are in the area where there is traffic islands, where we have provided traffic islands. Those are the regions where we have taken pylons. So none of the pylon is actually obstructing your traffic. Okay. All the pylons that you see in pink or magenta colored boxes are not obstructing the traffic in any way. So this was how the initial planning was developed. Is it clear? And that is the reason why an alignment like this was not taken, because if we would have taken this alignment, we would have to take something in between. It would have completely obstructed the traffic flow. So even though this is longer, it will be more expensive, but it is not obstructing the traffic. Okay, so this is how your plan looked like. And of course, this will be raised. I hope you understand that these pedestrian overbridges would be at a raised level. So if this is my bridge level, at this level would be your cars, isn't it? So your bridge will be raised. Okay. Your bridge will be raised above the traffic level, above the road level, typically around 6 meters or 5 meters clear height has to be given in case if some big trucks, or these days for tanks, military equipments or military infrastructure or military vehicles have to pass under it, the clear height should be sufficient for that also. So because you are at a raised level, to get down the road, to get down to the road level, you will need what? When you are walking on the footbridge, you are at a raised elevation. Now to get down at the road level, you will need what? You will need staircases. You will need some elevators, or you will need some staircases, isn't it? So therefore, the 2 staircases were provided over here. Clear? So there may be it may be a staircase, it may be an elevator, or it may be an escalator, whatever you provide, but it has to be provided at the starting and at the ending point, because people who are traveling on the footbridge, they are at raised elevation, and when they want to come down at the road level, they have to climb down or climb up the steps. So these 2 staircase regions were provided at the starting and at the ending point. So what do you see over here is a staircase assembly, and what you see at the end is another staircase assembly over here. Is it clear? And then you have elevators also. You have a lift that you have given over here, and you have a lift that you have given over here. So this is how your plan looks like. Any confusion with the plan? Hello? No, I think it's quite simple. All right, it's quite simple. Okay, so I stop over here. And then in our next session, we will continue with the further discussion. All right, so this plan, we will send it to you. It will be uploaded on the portal. I'll quickly demonstrate how to use the portal. So all of you will be signed in, or you will be signed on the portal. And once you enter the portal, it would look something like this. I'll just give you a brief walkthrough. Just hold on. Yeah, I'll just give you a brief walkthrough of the portal where you will be signed into. So when we add you on the portal, can you see this window? Hello. Yes. So all of you will be added on this window, sorry, on this portal. Then you need to go to this My Courses. So then when you click on this My Courses, you will be able to see. So right now I have just created a dummy account. You will see your name over here, and then you will see the courses that you are currently logged into. So if you are using this portal before also, you will see some additional courses featuring over here, whatever. Okay, right now I have only taken one. So this package you see, when you click on this package, you will see the two online courses that I was talking to you about. So this is the design and detailing of steel structure course, and this is the PEB course. So both of these have been added to your account. There will be another folder which you will find. Right now you cannot see, but you will see that maybe in the afternoon today, which will be the project 1 folder and pedestrian bridge. So whatever sessions or whatever information will be uploaded, it will be uploaded in this folder. Okay, and these two courses will be there for you to watch. Suppose you want to watch any particular course, you just need to click, then a new window opens up, and then your sessions appear over here. So you can see all the sessions are available right from 1 to 48. Suppose you want to refer anything in the PEV course, you go to the package and you go to the PEV course. So sessions 1 to 34 are available on PEV. So this is how you have to look into this. Is it clear? Use of this portal? Right. So we stop over here. Sandeep is asking why we are not providing why we are not providing staircase at second corner. You mean here? Here you mean? Hello. I think he is talking about this corner, that why we are not providing staircase over here. If suppose someone wants to get down at this corner, I think they figured out. So uh, this was this was based on the traffic flow, and this was based on the traffic movement. So they figured out that most of the people need to go from this place to this place, and very few people want to cross over here, or very few people want to cross in this direction. Most of the people want to flow from or go from this to this, and therefore they did not provide a staircase here. Okay, so they figured out by doing the traffic survey that people don't want to get down over here, or they don't want to cross here and here. Most of the people want to cross from this corner to this diagonal corner, and therefore they made this staircase. Sorry, therefore they did not provide any staircase here. Good. So this drawing will be uploaded on the portal. You can have a look at it. You can just try to understand the assembly, and then we will start our discussion on this tomorrow. So today is the first day. We are still warming up. So those who are into running, or those who are into long distance activities, or even in some sort of physical activities, we always do the warm up, isn't it? Before we start our workout, we always do the warm up. So today was sort of a warm up day, and therefore we will not have any session in the afternoon. We will directly meet you tomorrow morning. All right. All right. So that's all I had to present today. Thank you. Have a good day, and we will see you tomorrow at 8:30. Bye bye. Thank you. So tomorrow when we meet, we will be talking more about this bridge. We will be starting with the understanding of the geometry, and we will try to do some structural system finalization tomorrow. So it would be interesting. We will try to see what are the general systems adopted for pedestrian bridges, and what system will be suitable over here. That is what we would like to see tomorrow when we begin. So I hope things are clear today. That's all. Bye bye.